This is not my first time in Berlin. My first time in Berlin was in 1980. There was a wall running through the city in 1980. I was attending the University of Kiel, where they were desperately trying to teach me German. You should be happy you were not those people. And I ended up getting associated with a history class that was going to make a field trip to Germany. And in particular, they were going to go and spend a week in East Berlin. And I was allowed to join the trip, which has some interesting side effects because it turns out that the East German border guards were not expecting an American passport, but that is a different story. As a result, the first time I was in Berlin, I was in East Berlin, and I was in East Berlin for 1 week, and I was not really permitted to go to West Berlin because I had a single entry, single exit visa, which meant that if I did go to West Berlin, I could not go back to East Berlin. So for an American, it was a fairly unusual experience to spend a week in East Berlin having never seen West Berlin, and in some sense not being permitted to see West Berlin. I went back and saw West Berlin later. When I was in East Berlin, one of the things that I went to was the memorial for the Soviet soldiers in Treptower Park, which is not far from here. This is a photograph that is of a giant statue that is there. And if you have not been to the memorial and have not seen the giant statue, I encourage you to do it. And when I think of Berlin, curiously enough, I think of this statue because it really made a very large impression on me 35 years ago. And I don't want people looking at this to read any kind of political meaning into it. It has no political significance to me whatsoever. It simply reminds me of the first time that I was in the city. This is a city that I'm very fond of, and that is why I chose this particular picture. It has nothing to do with any political commentary of any kind. I will remark that one of the reasons that I like this is because this is from a victor in the Second World War, and he's carrying a broadsword. And there is another larger sculpture made by the same artist. It's in Volgograd, which is also worth going to see, which has Mother Russia, who also has a broadsword. One would get the impression from this artist that there were no guns used in the Second World War, which I always thought was kind of interesting. But I'm not here to talk about statues. What I'm here to talk about is what I've learned by working on effective C++ for 25 years now, something like that. And interestingly enough, the whole thing did not start with the book called Effective C++. The whole thing started a few months before that with a paper that I co-wrote with Meyers Lechter. It was called Initial Thoughts on a Lint++. And what we were trying to do was identify machine-checkable guidelines that would allow you to identify likely mistakes in your C++ programs. In 1991, this was still a pretty new language. It was new territory. The language, I will remark, was substantially smaller and less complicated than it is now. And so we presented a paper at a conference which had a bunch of machine-checkable rules. One of the things I have tried to do over the years is to identify rules that can be checked by machine. Those are the best possible rules you can come up with. If you're trying to figure out what are good coding guidelines, the things that can be automatically enforced, can be automatically detected, in my view, have always been the best kind. And although I have not been able to identify as many of them as I would like, that's still the gold standard for rules. So one of the things I have learned is that if you are going to try to come up with coding guidelines, one of the best things you can do is come up with rules that machines can check. And it has been nice to see that people like the GCC compiler and some other places have actually implemented warnings in their compiler based on some of the rules that I have published. But the thing that most people think of is Effective C++ actually came out the same year, in 1991. And I happened to think it was the right book at the right time. It wasn't really an introductory book, and it talked about how to use the language as opposed to what the language was. So that was kind of nice. 1995, I came out with more Effective C++ because the first book was easy to write. I thought, how hard can it be? So I wrote a second book. I actually wrote the second book in 1994. It was terrible. The reason that I know it was terrible is because I sent it out for review, and the reviews came in, and they said very diplomatically and very politely, "It is terrible." They didn't use those words, but if you care about what your reviewers are telling you, you look for what they're trying to communicate as opposed to actually what they say. So I rewrote the book, and then it was ultimately published, and it's not a bad book. I'm happy with the book. But the most important thing I learned from that was that a big advantage of the first book had been that the items were short. The first book, Effective C++, was actually inspired by a book I never saw, but a book that I read about. The book that I never saw but read about was called 50 Simple Things You Can Do to Save the Planet. And apparently what it was a 100-page book. Every double-page spread described a single thing that you could do that was supposed to be environmentally beneficial for the planet. And I said, that's a great way to put together information on how to improve C++. That would have been 2 pages per item. 50 items would have been 100 pages. Didn't seem like it was going to be that much work. The book ended up at 197 pages, so it was almost 4 pages per item. With 4 pages, you can't really go into a lot of detail in deep, meaty items. So in more effective C++, I had the beginning part, which had some short items, and then I had a second part, which had deeper, meatier items. They ran 10 pages in some cases. They ran 20 pages. And once the book got published, we discovered very quickly that the really long items appealed to comparatively few people. People really liked the idea of bite-sized chunks of information. And so I have tried to bear that in mind in all of my subsequent publications. People don't like reading 20 pages of information about a particular topic. 1997 was the second edition of Effective C++. It was sort of a freshening up of the first book in taking into account what had gone on in standardization. Interestingly, to me, when I think about this book, what I am most reminded of was people who looked at the cover of the book. And they looked at the image on the cover of the book. You would be amazed at how many people said to me, "Why did you put a polar bear on the front of your book?" So I have a question for you. Ice bear, wolf. I mean, I was surprised that people were so confused, but it wasn't just 1 or 2 people. It was a lot of people. So, for the record, it's a wolf. 1999 was the first time we actually tried to do digital publication. The content of the Effective C++ CD was the same as the content of the books for the most part, so there wasn't any actual new writing, but it was the first time that I tried to figure out how can we communicate the information that we're trying to get across in a mechanism other than simply as ink on paper. And how can we take advantage of the capabilities of HTML and related technologies to give people sort of the experience of working at a website that knows all the information that is in the books. One of the things that we did that I thought was very, very clever, I know that a lot of people wrote coding guidelines that referred to items in my book. It was very common for companies to have coding guidelines that would say, blah, 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 for details see Scott's book, blah, blah, blah. And I thought, let's make it easy for people to do that. And so we came up with a mechanism so that every individual paragraph on the CD had something you could click on, and that would give you a URL, which you could then link into. And I thought, this is great. And from what I can tell, the number of people who use it is 0. So it was an attempt to sort of make things easier to use in a way that I thought was obvious, and from what I can tell, no one liked it. One person who did a review of it called it a classic case of over-engineering. I still think it was a good idea. 2001 was Effective STL. Effective STL adhered to the general approach I'd been done in the past, but this book was different for an important reason from my perspective. This is the first time this was a 2-color book. And so I went to my publisher and they said, yeah, we will spring for buying a second ink color, which makes the printing process more expensive. It also turns out that it leads to some really interesting new kinds of bugs in books. I actually went and saw them publish that book, and you have these giant sheets of paper that go over rollers with ink on them. And after they've gone over one roller to get one color ink, they go over a different roller to get a different kind of ink. And what that means is things have to be aligned extremely precisely, or else you end up with the baseline of the text in one color not quite lining up with the baseline of the text in the other color. And we started getting bug reports from people about words not lining up correctly. But this was the first time that I was trying to use something other than black ink on white pages to communicate to people what they should be looking for, what was a good idea, what was a bad idea. I also did something which worked well for me, which is I changed the font that I used for code. Up until then, I'd always used Courier or some other fixed pitch code. And what I decided to do for effective STL was to use a variable pitch font, which means that it didn't look like anybody's code in anybody's text editor, which people noticed. But it had the advantage from my perspective as an author, I could fit a lot more characters on one line, which turned out to be important because in many cases I was trying to communicate, here's the code and here's the explanation of the code, and I didn't want to have to break that across multiple lines. So that was the first time I really tried doing something a little bit different. I deliberately made it not look like text editors, not because I didn't want to look like text editors, but because I thought this will allow me to get my message across in a cleaner, more effective fashion. As a historical tip, I'll point out that when I wrote the second edition of Effective C++, the one that does not have a polar bear on the front of it, the cover photograph I wanted to use was this one, which is a baby crocodile crawling out of an egg, which I just think is adorable. And when I went to my editor at the time and said, I think we should use this image on this book, so this was in 1997, my editor, who has risen very, very high in the hierarchy at Addison Wesley because he's very, very smart and very, very good. And what he said was, well, he goes, we could do that if you want to. If you want to have the alligator on the cover, that's okay. He goes, but if I was working in a bookstore, and back in 1997, people still did work in bookstores. If I were working in a bookstore and I had to look at animals facing me all day long, I would much rather look at a cute little wolf pup than look at an alligator. And from a marketing point of view, we really would like our books to be displayed face out, not spine out. This is why he's got the big corner office high up in corporate headquarters. So that's why we ended up with the wolf pup. We got the alligator here. Third edition of Effective C++ was essentially the same as Effective STL in terms of formatting, no new information there. And then the book that I just wrote called Effective Modern C++. This is the first book we have that's a 4-color book. So it's got full color on the inside. And I went back to using a Courier font for code simply because people had complained about the code that I had been using before. This is the first book I have written that assumes that there was a large amount of information that readers have already absorbed. In particular, for effective modern C++, I am now assuming that everybody understands basically everything that there is in C++ 98, which is quite a large assumption. I've never done that before. As a result, it made the book probably the most difficult one that I've had to write. And perhaps another reason, well, we'll come to that in a moment. So that's sort of the history of the Effective C++ project, and you don't really want to listen to me talk about what happened in the past with these books. My wife does not want to listen to me talk about it, and she vowed to care what I think. So I want to talk about something a little bit different. What I want to do is try to take the lessons that I've learned from working on these books and other things over the course of the years and boil it down into information that I hope will be useful to you as you are trying to come up with your own programming guidance or make sense of the language or just communicate with other people and possibly persuade them how to change their programming behaviors. So there's just 2 fundamental questions I want to deal with. The first question is, what do you say? And the second question is, how do you say it? At the end of the day, that's really what I've been working on for 25 years. What do I tell people? How do I tell it to them? So I want to start by talking about what things you need to talk about. A couple of years ago, I put together a blog post. It's there on the left-hand side. It was called Effective Books. And what I tried to do was summarize the guidelines that I had come up with for if you want to write an effective book, how do you go ahead and do it? And I came up with 13 guidelines for doing that. I needed to come up with this information anyway because I am a series editor for Addison Wesley, the Effective Software Development Series, and I would get a lot of book proposals from authors who wanted to write something for the series. And I always thought it was pretty straightforward how to write an effective book. And I would get these proposals, and it was very clear that what I was thinking was not at all what they were thinking. So I ultimately wrote up a list of 13 guidelines if you choose to try to write a book like Effective C++, and you don't have to, but if that's what for some reason you've chosen to do, these are some guidelines that you would want to adhere to. Notice that number 1 is keep items short. That's the more effective C++ feedback right there. And it ends with seek out ruthless pre-publication reviewers. The more ruthless, the better. That's how you find out that you've written a really bad book before you publish the really bad book. I would much rather know that I've written a bad book before I publish it. I prefer to have a chance to fix it. And I'm not going to have time to talk about all of these. What I'm going to do is I'm going to talk about 3 of them, and I'm going to try and give an example. One of them is I want to talk about this guideline to word item titles carefully. I have been surprised at just how sensitive people are to exactly the way that I word things. And with my most recent book, it's sort of funny because now people are trying to convince me by flattering me. They go, you know, Scott, your books will be so influential. It's really important that you not mislead people into doing blah, blah, blah. I'm thinking, well, thank you. I hadn't planned on misleading people in the first place, but now that you've told me not to do it, I'll be sure not to do that. When you are dealing with C++ software developers, nothing is as persuasive as a solid technical argument. People who program in C++, they are very smart people. And of the very smart people who program in C++, most of them don't read books. Most of them don't go to conferences. The people who read books, the people who come to conferences, people like you, are more interested in the technology than most, have more motivation, more ambition than most. So if you're trying to convince people like you, you'd better have a pretty solid technical argument that you can bring to the table. Hand-waving is not likely to convince you people, nor is it likely to convince people who are reading technical documents. There is no substitute for a solid technical argument. And then I do want to talk about the utility of getting ruthless pre-publication advice from people who can look over what you've written about. And I want to do this in terms of a case study from the new book. One of the reasons I like Berlin is because my publisher decided that when they had the book, they weren't going to send it to my house, they'd send it here. So this is the first book I have ever seen. So currently, no one has opened it, and therefore there are no bugs. It's perfect. OK, there's an online errata list, but we'll ignore that. So I want to talk about item 42 in the book. I need to mention something about item 42. A friend of mine in Australia was reviewing the book, and anytime I had a constant, he would say, ooh, use 42. I would say int x equals 0. He'd go, ooh, 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 should be 42. If you're writing books, you have to come up with a lot of constants for examples and stuff like that. So some of them there's meaning to. I've got various people's birthdays and ages and stuff like that scattered throughout the book. But sometimes you just need a number. Well, his number was 42. Ooh, ooh, 42. You should use 42 there. So there's 42 guidelines in the book. That is in his express honor. And this is guideline number 42. Guideline number 42 originally was going to be prefer emplacement to insertion. That was my original guideline. And I thought, this is really easy. This is really obvious. I can write this down, knock this off in a couple of days. And in fact, I waited until the book was almost completed before I wrote this down. So just out of curiosity, how many people offhand think that's a reasonable guideline? Yeah, so some people think that's a reasonable. I thought it was a reasonable guideline. With any luck, by the time I'm done, none of you will think it's a reasonable guideline. But I thought it was a good guideline. It is based on the following observation. We have insertion functions and we have emplacement functions. Insertion functions are operations on a container of T, and an insertion function adds a T to the container. So it's a container of T. An insertion function takes a parameter of type T, which gets added to the container. So the insertion functions are push front, push back, insert, and insert after if you are so unfortunate as to be using forward list. And as an example, if I have a vector that holds strings, then push back takes a string and takes a string. Now, they're actually references to string, but for our discussion, I don't care that they're references. What I care about is they take objects of type T. Yes, they're references, but that's not important. That's what makes an insertion function. An insertion function for a container of type T takes objects of type T. That's what makes it an insertion function. Most common ones, push front, push back, insert. Emplacement functions. For an emplacement function for a container of type T takes constructor arguments for objects of type T. So it actually takes the arguments that can be used to construct an object of type T. In place front, in place back, in place hint, and they should be in place after. You would think that I would have gotten this right. Or maybe you wouldn't. All right, so should be in place after. And so in place back, for example, takes 0 or more arguments that are passed by reference. But we don't know what the types are because we can't say what the constructor is going to be taking. It's an object of type T. We have no way of knowing. So insertion takes an object of type T. In place takes constructor arguments for type T. The advantage of the emplacement functions is that they can help you eliminate the need to create a temporary object that would otherwise be necessary just to satisfy the insertion interface. So for example, if I have a vector of strings and I want to push back of the string literal x, y, z, z, y. Now, pushback is an insertion function. We have a vector of string, which means pushback's parameter type is string. But we're not passing a string. We're passing a string literal. Now, this code will compile. The compiler generates code to create a temporary string object from x, y, z, z, y. It then takes that object and it moves it into the vector, and then it destroys the temporary object. So create temporary, do a move, destroy temporary. If instead we call emplaceback, emplaceback takes constructor arguments. So what emplaceback does, it takes the string literal x, y, z, z, y, and it then constructs the string from it directly in the memory for the vector. As a result, you do not pay for a temporary object. There's no temporary constructor. There's no temporary destructor. You simply create exactly one object, and you can't do better than that. This is the attraction of the emplace functions. They avoid the need to create a temporary object simply to satisfy the interface that is imposed by the insertion functions. Furthermore, if I wish to create, let's say, a string from another string, that's either going to be copy construction or move construction. Copy construction or move construction. They're both constructors, which means I can pass an object of the same type to an emplace function, and it will then construct the underlying object, either using copy construction or using move construction. So if Donna Summer is the queen of disco and she's a string, then I can do a pushback on queen of disco. This is going to copy construct queen of disco at the end of the vector. And if I do an emplace back of queen of disco, now this is a constructor argument, but we have a constructor which takes an L value of type string, which means this will also copy construct queen of disco at the end of VS. They do the same thing. Which means if you prefer emplacement to insertion, it should never be slower, and it should sometimes be faster, because it avoids the need to create a temporary object. Right? You can call it with exactly the same set of arguments as you can call the insertion functions. but you can also call it with more arguments. If you call it with the same arguments as the insertion functions, it does the same thing as the insertion function. And if you call it with arguments that are of a different type than the insertion functions take, you avoid the need for a temporary. Now, how many people think it is a reasonable piece of advice to prefer emplacement to insertion? So this is what I wrote up, and I sent it out for technical review to some people I know who are way smarter than me. One of them was Stefan Lawade. He's the guy in charge of the STL at Microsoft. And he said, you know, Howard Hinnant, how many people know Howard Hinnant? Howard Hinnant, all-round really smart guy, on the standardization committee, father of move semantics, person who can't get enough cold weather, would move to Antarctica if it were possible, and one of the nicest people in the world, also the author of the C++ standard library for Clang. Smart guy. So Stefan said, you should take a look at Howard because he's done some interesting research recently that might change your mind. So what Howard Hinnant did was he did some very simple experiments. He had a vector of 3 objects, 3 elements in the vector. And then what he did was he would either insert an element in the front or he would emplace an element in the front. There's no type conversions going on. He's inserting a T into a container of T's. That's what he did. And he did it first. He considered the possibility that the container has excess capacity, which means no reallocation is necessary. So the capacity is greater than the size. And then he also did it where the capacity and the size were exactly the same, which means you would have to do some reallocation. And he did it for L values and he did it for R values. But Howard is very, very meticulous. So when he distinguishes L values and R values, he recognizes that there's actually 2 kinds of R values. L values are L values. But R values, you can have what is known as an X value. Now, an X value stands for expiring L value. How many people are familiar with X values versus PR values? I feel so sorry for you. I'm sorry, honestly. And now I'm going to tell everybody else, so I'm sorry for you too. An X value is an expiring L value. It means that you've got an L value and you're turning it into an R value. Normally, the way that happens is by you call move on an object. So you have an object, it already exists, it's been constructed, and now you're turning it into an R value by calling move on it. That's an R value, but it's an X value. It used to be an L value, and now it's an R value. The key thing about X values, and the reason they're important, is because they have already been constructed at the time they're turned into an R value. The other kind of R value is known as a PR value. That stands for a pure R value. That is an object that is constructed as an R value. It's never cast to be an R value. It starts life as an R value. It's constructed usually in the same expression that you're dealing with. So for example, if I create an object of type T by casting some constructor arguments to a T, the object that is thus created doesn't have a name. It comes into life as an R value. It actually offers some additional optimization opportunities to compilers compared to X values. And as I mentioned, Howard is very meticulous. So Howard did this experiment on 3 different implementations of vector. His own, libc++, that's the library for LLVM. libstandard C++, that's the GCC library. And Visual Studio 2013 from Microsoft. He did the experiments this past summer, and at the time, that was the current Microsoft implementation. So here's the first set of results. This is when there is no reallocation necessary. And we're dealing with an L value insertion at the front of a vector of 3 objects. I want to emphasize here, the bar chart is showing you how many functions are executed. This is not time. This is how many functions are executed. And the color coding is telling you which functions are being executed. You probably can't read it, the key's up here. But for example, green, those are destructor calls. And this purple color here, that actually is a move assignment operator. So each one of those colors corresponds to a particular function that is being executed. So let's take a look at just this very first example. This is an L-value insertion into the front of a vector of 3 objects where there is some additional capacity. So this is the results for insert. These are the results for in place for libc++. Results for insert, results for in place for libstandard C++. Results for insert, results for in place for VS 2013. We are adding an object of type T to a container of T. I told you before that at least in concept, emplacing a T is exactly the same as inserting a T, because there's no type conversion going on. We would expect them to have the same behavior. Three sets of results from 3 independently developed libraries. Insert and in place do not call the same number of functions in any implementation. All right? For libc++, insert runs faster. When I say faster, I mean executes fewer operations. This is not time. This is execution of operations. So insert looks better. At libstandard C++, in place looks better. Microsoft's compiler, insert looks better. That's the kind of consistent cross-platform behavior that we're always looking for. And the other thing is, even when insert executes fewer instructions, notice that Microsoft's compiler executes a whole lot more operations than libc++. Well, that's interesting. That's L values. So this is X values. Again, we've got the same 3 implementations. And in this case here, if you're dealing with libc++, insert executes fewer operations. But libstandard C++ and VS 2013 execute the same number of operations for, and in fact, if you look at the color coding, you can see they look exactly the same, which means they are truly executing the same code. Yes, finally they're doing what we expected them to do in the first place. So it's nice to know that 1, 2 out of 1, 2, 3, 4, 5, 6. 2 out of 6 times it's doing what we would have expected. God, I hate empirical data. So here's a PR value. We get similar results. Insert is faster with libstandard C++, and it's a tie at, with libc++, and it's a tie with libstandard C++ and with Visual C++ 2013. And if you do the same thing for when reallocation is required, because Howard published those numbers as well, it looks like this. And I looked at this, and I thought, you know, there's an awful lot of variability here for something which is supposed to behave identically because it's doing the same operation. And in particular, the number of functions executed varies not just for a particular scenario, like whether we're adding an X value in a container which has excess capacity. It also varies across compilers, to be quite precise, across library implementations for a particular scenario. Whether insertion or emplacement executes fewer operations, that also varies from platform to platform. And whether emplacement is equivalent to insertion, which remember, conceptually it's supposed to be, also varies. So I looked at this and I went, well, I mean, I could just ignore it and hope nobody finds out. C++ people are smart. They would figure it out. But there was actually a deeper insight when I looked into what was going on here. So it is common when people are trying to figure out How much does something cost? They'll do things like, how many copies do we make? Or how many moves do we make? Very, very common. Let's count the number of copies, let's count the number of moves. And there's a problem here. The problem is that assumes that all copies cost the same thing. Even for a particular type like string or vector. There's two ways you can copy a type. You can do it by copy construction. You can do it by copy assignment. Our tendency is to assume that copies copy, but in fact that is not the case. Copy construction behaves differently from copy assignment. And so to me, the insight was that construction of an object is fundamentally different from assignment of an object, because construction can take arbitrary types. But assignment, by convention, takes exactly the same type of object. Now, this becomes important. Remember, the motivation for preferring emplacement, and in fact, the technical reasoning behind why emplacement runs faster, is it avoids the need to create a temporary object of a particular type. That's its advantage. But the assignment operator, for example, for a widget, assignment by convention, there's two assignment operators. Here's copy assignment, here's move assignment, but notice that it takes a widget in both cases. The constructor, on the other hand, can take anything. Construction is a much more flexible process. Assignment is a constrained process. Now, you might be thinking, okay, for some types, though, we know that people actually change the assignment operator or offer an additional assignment operator so they don't have to take exactly the same type. And that's what I thought. And the first one that came to mind for me was string. I know that string can be assigned from a string literal, which makes sense. And I thought, great, that will avoid the temporary. But like an idiot, I looked it up in the standard. There is an assignment operator for string in the standard that takes a string literal, but it is defined to be the same as taking that string literal, turning it into an object, and then calling the normal assignment operator. So yeah, it's there, but there is no reason to expect that it's going to run any faster. But what this tells us is that if we're going to use an emplacement function, and we're going to give it an argument which has to be converted into the type of the container so an assignment can take place, if an assignment will ultimately take place, we are going to pay for the temporary construction of the object of the type demanded by the assignment operator. And when that happens, there is no reason to believe emplacement to run any faster. So now we need to ask ourselves, for a particular operation on a container of T, if we're adding something to that container of T, how will it ultimately be added? Will it be added by assignment, or will it be added by construction? If it's added by construction, emplacement has a chance of running faster. If it's going to be added by assignment, there is no reason to expect that to run faster. So, emplaceback can beat pushback, because emplaceback is performing construction of an object into a chunk of raw memory. There's no assignment taking place here. I'm assuming that there is extra room in the container. Similarly, emplacefront should be able to beat pushfront on containers that support it, because we're constructing something into brand new memory. But a general purpose call to emplace, there is no reason to expect it to beat insert, because a general purpose call to emplace is going to be making an assignment to a chunk of memory which already has an object in it. That assignment is going to require that the arguments passed to emplace be turned into a temporary object of the appropriate type, which we will then do an assignment with. Yes? Okay, so the question is, could we adopt a policy of implementing assignment essentially as a constructor-destructor pair? So the question is, could emplace do it that way? So I would have to sit down and actually work through it to find out. My suspicion is that it's probably possible, and I will argue that it doesn't matter. And the reason it doesn't matter is because as somebody who is using a standard library written by unknown third parties, there is no way I can guarantee that it is implemented that way, even if it is a valid implementation. So as a library client, the existence of a theoretical perfect implementation doesn't guarantee me anything unless I am guaranteed that they use that theoretical perfect implementation. And we've clearly seen data from Howard's results that show that these implementations are all over the board in terms of what they're doing. So, my answer to your fundamental question is I don't know. I'd have to actually sit down and work through the steps. But from the point of view of my broader point here, it really doesn't matter. Because even if there could be a perfect implementation, it may not be used. I'm going to keep going. We'll have time for questions at the end, because I have a whole bunch of other stuff I want to confuse you with. All right, so where we stand right now, we have some conclusions so far. I'm not done, but let's sort of take stock at where we are. The first thing is, emplacement into a container of T is a potential win only when certain things are true. I mean, I used to think it was true all the time, but now that I have some data, pesky Howard, I have some new conclusions. The object has to be added to the container through construction, not through assignment. Now, this is a really interesting situation. What this means is when I call a function to add something to a container, I'm somehow magically supposed to know how it's implemented internally. If it happens to use assignment internally, I'm probably not going to get any performance improvement. If it happens to use construction internally, I probably am, or I might. So that is a really different way of looking at it. Number two, if multiple arguments are passed. Now, if multiple arguments are passed, remember that the insertion functions take one object of type T, one object. So if I'm passing multiple arguments, I must be calling a constructor to create the one type that I need. So emplace might be a win if I have multiple arguments to pass. Or if I have a single argument to pass, if I've only got one argument, but it's not of type T. We've already decided that emplacing a T ideally does the same thing as inserting a T. And remember, we're trying to figure out when does emplacement win? When is it better than insertion? So if it's going to do exactly the same work as insertion, it's not a win, it's a wash. We're trying to figure out when emplacement is better. Now remember, my original potential guideline was to prefer emplacement. So if I'm going to encourage people to prefer emplacement, I have to be able to say, look, it will be better. So that's my tentative set of conclusions. But let's move on to quux. My term, not a standardization term. Quux, a container with a unique key. Set and unordered set are containers with unique keys. They hold objects of type key. So they're typically implemented either as balanced binary search trees for set or as hash tables, which may or may not look like this as unordered sets, but conceptually they look like one of those two things. Or we have maps, which essentially are the same thing except they have key value pairs. So if I have a map or an unordered map, a map is a balanced binary search tree with key value pair. Hash table has a bunch of key value pairs. Again, it may not look exactly like this in memory, but conceptually this is what it looks like. Those are quux, containers with unique keys. I don't think we've looked at enough at the standard recently. So here is an excerpt to make you feel comfortable and grounded. These are simply the declarations for set, unordered set, map, and unordered map. And what I've highlighted for you is the default comparison operation. The default comparison operation for a set is less of key. For unordered set, it's equal to of key. For map, it's less of key, and here it's equal to of key again. And you might wonder, why do we care? We care because the default same value comparisons are homogeneous. If I'm going to add something to a unique container, a quux, a container with unique keys, It doesn't get added if the value is already there. But how do we find out if the value is already there? We use the comparison function. What does the comparison function take as its parameters? Two objects of the same type. Now remember, the advantage of emplacement was that it avoided the need to create temporary objects. It could just create something directly in the memory. But if you can't do the comparison to find out whether something is a duplicate until you've created an object of the appropriate type to do the comparison, you will not avoid the need for the temporary object. So it's not the assignment interface in this case that's giving us trouble. What's giving us trouble is the comparison interface, which is expecting an object of type key. So emplacement doesn't take keys, it takes constructor arguments for keys. But now we realize we're going to probably have to pay for the construction of a key object just to do the comparison. Which means there's no reason to expect emplacement to run any faster. Except it's much, much worse than that. Not worse, much, much worse. So here's how insertion works. If you want to insert something into a container of unique keys, what you do is you take this object which you're thinking of adding, and you've got this container, and you compare it to all the keys in the container, looking to see if it's there. Because you need to find out if it's a duplicate. If the parameter is not in the container, now you know it's unique, but you have to add it to the container. So what you do is you dynamically allocate a new node, you copy or you move the parameter into the new node, depending on whether you've got an L value or an R value. You link the new node into the container. Seems pretty straightforward. Important, if it's a duplicate key, if I'm not adding something to the container, if it's a duplicate, then we don't allocate a node, or we don't copy or move the key, and we don't deallocate a node, which makes sense. I mean, why would you create a node if you're never going to use it? That would be dumb. Speaking of such, let's talk about emplacement. With emplacement, step number one, you dynamically allocate the memory for a new node. I am not kidding. Then you construct the key in the new node. I am still not kidding. I checked 3 standard library implementations. They all behave like this. And then, because I decided that I had not suffered enough in my life, I checked the standard. And from what I can tell, this is required behavior. Now that you have a node that's been created that you may never need, you do a comparison of the key in that node to all the keys in the container until you find out whether it's a unique value or not. If the new node isn't in the container, then what you do is you link it in. Otherwise, you destroy the new node. Which means that for duplicate keys, a node is allocated and is deallocated, and the key in the new node is constructed and destructed. It means that emplacement for quux of a duplicate value is vastly worse than insertion. So, practically speaking, as I said, I did very simple tests on 3 implementations. They all behave as I am describing. And when I look at the standard, I believe the standard requires that. But even if the standard doesn't require that, even if everybody who is implementing these libraries fell down and hit their head, it doesn't matter because this is how things behave right now. I'll take questions later. So now we have an additional conclusion, which is that emplacing into a container of T probably is a lose. It's probably worse than insertion when the container rejects duplicate keys and duplicate keys aren't uncommon. Now, if you're not using a quux, or if every insertion you expect will not be a duplicate, then it doesn't matter. That's kind of interesting. Well, in the meantime, I had received email from another person telling me that their concern about emplacement over insertion had nothing to do with performance. It had to do with type conversions. If I have a vector of regexes and I do a pushback of null pointer, this is an error. I hope this is an error. I have a vector of regexes. This is a null pointer. A null pointer, in fact, a pointer is not a regex. This code is rejected. It should be rejected. There is no implicit conversion from a null pointer into a regex. Yay, type checking. Oh, that's not what I wanted. I don't even know what that did. Conceptually, these functions do the same thing. Something weird is going on. So we go back to the C++ 14 standard because that's a good place to spend time if you have nothing else to do. This is the constructor in question. It's the basic regex constructor. It's explicit. It takes a pointer here. Now, this is a quote from the standard. This is a quote from the standard. This is a quote from the standard. Now, what that means is that if you call ImPlaceBack with a null pointer, it doesn't matter if it compiles or not. This is a precondition violation. You've passed in a null pointer when the requires clause says you're not supposed to. So the behavior of the program is undefined, just in case you were thinking of writing production code that does this. But that's not the interesting question to me. The interesting question is, why is ImPlaceBack compiling when pushback is not compiling? That makes no sense to me. But, you know, I tried a whole bunch of implementations. They all did the same thing. That's annoying. How many people know the difference between direct initialization and copy initialization? Excellent. Almost no one. This is one of the things that the standardization committee does after they've been cooped up in a room for 5 or 6 days. They start arbitrarily sprinkling these phrases through the standard just to see if anybody's paying attention. This is what it boils down to for our purposes here. Direct initialization can call explicit constructors. Copy initialization can't. If you don't believe me, you can look it up. Section 8.5, paragraphs 15 and 16. Now, you might think, great, when do we use copy initialization in C++ and when do we use direct initialization? And the answer is, it's very easy to know. You simply memorize it on a case-by-case basis. There is no overarching logic that I have been able to discern. So as an example, if I create a regex from null pointer with parentheses, that's direct initialization and it compiles. How do we know it's direct initialization? Because that's what the standard says. If you use parentheses, then it's direct initialization. If I use curly braces, because now we're all into uniform initialization, this is also direct initialization. It compiles, because it can call explicit constructors. If I use an equal sign, I'm sorry, that's copy initialization. It cannot call explicit constructors. Homework for you. What happens if you use equals and use curly braces? Different talk. Emplacement uses direct initialization, which is why this compiles. Insertion uses copy initialization, which is why this does not compile. Extra special homework for mega bonus points. Back this statement up. I had to look this up to find out, to really make sure that this was true. It was fun. So those of you on the standardization committee, you are required to do this. All right, so there is a difference between these two. One of them uses direct initialization internally. One of them uses copy initialization internally, which means that they behave subtly differently. Which means we have one additional conclusion to the add to the ones we had before, which is emplacement is less safe than insertion in the sense that it permits more constructors to be called. In particular, it allows explicit constructors to be called that would be rejected by the insertion functions. And if we add all of these things together, this is the way that, this is my current understanding of the situation. First, Emplacement can reduce the number of constructors and destructors. That was the original motivation for the guideline to consider using emplacement. That continues to be true. And I have talked to people working on real projects who have run real profilers on real programs, and they have told me that shifting from an insertion function to an emplacement function actually made a noticeable improvement in the behavior of their program. It is not a theoretical advantage. In theory, emplacement does not cost more than insertion. I was fortunate enough to be able to discuss this a little bit with Stefan Lawade, the man who does the Microsoft STL implementation, as well as Howard Hinnert, who does the LLVM Clang implementation. And they both seem to think that, in principle, there's no reason why emplacement shouldn't be the same as insertion or better, in principle. In practice, emplacement is often faster. So if I try to figure out, okay, well, when should you use emplacement? Because at the end of the day, that's what people want to know. When does it make sense to use emplacement? Well, if the value being added is constructed into the container, not assigned, which means you have to have some idea how it's implemented. Fundamentally, it means the chunk of memory that the new value is going into doesn't currently have anything in it. Push front qualifies, push back qualifies. Inserting or emplacing into the middle doesn't. If the arguments being passed are different from T, assuming you have a container of T. In other words, if you can avoid the need to create a temporary. And if the value to be added is unlikely to be rejected as a duplicate. Those are the conditions where emplacement looks like it's a good bet. It is also worth noting, setting aside performance, that insertion respects explicit constructors and emplacement does not. You can argue back and forth as to which is better, whether you should call explicit constructors, whether you should not call explicit constructors. I'm not going to make a value judgment as to which one of them is better. What I will say is they don't behave the same way, and that's worth taking into account. So my guideline originally was to prefer emplacement to insertion, but after getting feedback from people, I decided that's not a reasonable piece of advice any longer. Instead, I changed it in the final book to consider emplacement instead of insertion, which is really wishy-washy, but I don't know what else to say. That the best I can do is explain to people what I've just explained to you, and then have them bear in mind that under some conditions, emplacement is probably a good idea, but under other conditions, insertion is probably a better idea. But a more detailed guideline as to when you should use which one, that I can't give. And I would not have been able to come to this level of understanding of the factors involved had I not sought out comments from these people, or in some cases, Michael Winterberg actually just sent them to me spontaneously. So one of the nice things about seeking out ruthless reviewers, people who really will say, Scott, you're so naive, leads to a deeper understanding. Now, one of the things that I like to tell people, only because it's true, is that my wife likes to point out that no one should have to listen to me talk for more than an hour at a time. It's been an hour. So what we're going to do is take a break for 5 minutes. So enough time to stretch, maybe get a chance to get the blood circulating again. Because all I've talked to you so far is about what to tell people. I want to now talk about how to tell it to them in 5 minutes. All right. I am very concerned. I am extremely concerned. It is beginning to sound like you are having a good time, and we cannot have that. This early on the first day, no good times. I just gave you an example case study of how I went about coming up with the final piece of advice that ultimately appeared in effective modern C++. But I said that there's two aspects to the effective C++ project, as we might call it. One of them is figuring out what to say. And that's what most people focus on. I want to focus now on how to say it, because you can have the best advice in the world, but if you don't present it in a way that people can consume, in a way that people find attractive, in a way that people find compelling, it doesn't do you any good. Truth alone is not enough. So I want to talk now about getting the word out. Once you've come up with what you consider to be a great piece of technical guidance, how do you get the word out? And in 1991, it was pretty straightforward. You wrote and published, and you gave talks. That's pretty much what you did in 1991. But we are in a whole new millennium now. Things are radically different. Not. But they are different. You still write, and I want to make a plea here for writing. It is easier than it has ever been. It will only get easier to record presentations such as this one. I'll be talking about recordings. Or to upload things to SlideShare. It is easier than it has ever been to avoid sitting down and writing an article or a detailed blog post or a book, and to convince yourself that's okay, I got the word out because I gave talks or I put my slides available somewhere. They're not the same. In my experience, an actual well-written article is almost random access. You can skim through it looking for the good parts. Really hard to do with videos. And you have to say every single word to really make your argument. You don't leave these giant gaps between thoughts like you do with slides. Now, I like slides. I publish them myself. I like talks. I like talks. They gave me a 2-hour slot. I never shut up. Writing continues to be important. It complements these other ways of getting the information out. It's a pain, but it's worth the trouble. So writing and presentations. The really new thing is video, which has some interesting impacts, which I'll talk about in a bit. So this is the writing landscape, 1991. Life was good. Life was easy. As somebody who was going to be writing, you knew exactly what you were going to do. You were going to have little dots of black ink on bigger pieces of white paper. You knew how big the pages were. You knew how tall everything was. You could choose the appropriate font size. So this is from an article that I wrote in 1991. This is from the first edition of Effective C++. It was just easy. You could make sure things looked good. In 2009, I was invited to give a talk at a publishing conference called Tools of Change, which I thought would be a really good opportunity for me to go in and explain to the publishing industry what I thought needed to change in order to take advantage of newer technologies. And what I found out was that almost everybody there was interested in the business side of things. And so they just sort of took it for granted. Oh yeah, and then there's authors. So it wasn't the right audience for the talk, but what I want to do is I want to talk a little bit about, I'm going to show you some slides that I did in 2009. So we're going back in time. I'm going back in time 5 years now. I just want to talk a little bit about my vision for the way I think that people should be approaching the problem of writing circa 2009. It's truer now than it was then. So at a high-level concept, and it doesn't matter whether you're writing a book or you're writing an article, it doesn't make a difference. How long the writing is actually is not important from my perspective. What's important is this. The author has an idea of some information that they want to convey, and ultimately you'd like to publish it in print form, on a computer screen, on some kind of a portable electronic device, on a multi-purpose device like an iPhone or something like that. I'm not going to talk more about it, although I will say I still have this idea that for some kinds of content, it makes sense to consume it purely as audible form. Software Engineering Radio, for example, is a technical podcast which only has audio. And I believe that it is possible to produce content that can be consumed in audio form, so your eyes are not required. I wouldn't want to listen to too much C++ source code. But I might want to listen about data structure design. And the key thing I want to get across is that the information that's here is going to affect how easy it is to perform all of these various transformations here. And what I found is that the publishing industry, at least the book publishing industry, they tend to assume that authors will write, and then we'll deal with it later, and we'll worry about what happens afterwards, after the manuscript has been delivered. But my thing is that if the information that you need is not in the manuscript, it's going to be really hard to add it over here later. So, yeah. All right, so, ideally what we want is a manuscript from an author that is platform agnostic, doesn't know how it's going to be published. And then ultimately what you're going to do is you're going to publish it in all these various forms here. But this document here, whatever is delivered by the author in the first place, it should contain information that makes it possible to exploit the strengths of a platform. So if a platform, for example, has support for color, support for video, if it allows you to dynamically change line breaks, the manuscript should accommodate all of those things. Those are strengths of the platform. At the same time, it accommodates their weaknesses. So if you have an output device, we can call it a book, which isn't dynamically anything. It's little bits of ink on pieces of paper. That's a very primitive output device. But it's an important primitive output device. The author should take into account the fact that both of these devices are being targeted. So again, this is from 2009, so this is a long time ago. What I just want to point out is that if you sort of look at the criteria and the capabilities of these different platforms, there's a tremendous amount of variability. Maybe you got color, maybe you don't. Maybe you've got dynamic line breaks, maybe you don't. Maybe you can personalize it for the individual who's reading it, maybe you can't. It's all over the board. What some publishers do, in my experience, some of it extremely recent, is they take a conventional manuscript from the author and they at least mentally assume it's going to be printed in book form. That's what they're thinking, and it's possible that that's actually what their input system expects. And then what they try to do is derive all these other forms from it. So up until very recently, one of my publishing houses took my final book in PDF. And that's what they used to convert it, for example, to Kindle or online, which means they had no information about anything to do with the structure of the document. All they had was PDF. That was their point of departure. If you do this, if authors are thinking, okay, I'm going to write a print book, then authors are going to write books that are static, that are monochrome, that are based on the idea of pages, and that are visible as opposed to something you can listen to, which means all the other formats are going to suffer. Basically, authors are going to write for particularly dim output devices that don't have a lot of capabilities. That doesn't serve anybody. It doesn't even serve the authors. That's interesting. Oh, that's kind of cool. We're missing, actually, the top line. So the question is, what can we put into a manuscript which could be published any place? So we got the usual suspects. We got text, we got diagrams, tables, photographs, that kind of stuff. We've also got color, we've got video, we've got animations, we've got audio, and you'll have to excuse my playing around with PowerPoint. Remember, this was 2009, and I was just having a little bit of fun. So we need for authors to start thinking about writing as more than just a sequence of words, typically in one color, on paper. And my experience is that the publishing world doesn't yet get this, and the authoring world doesn't yet get this in general. Now, there's some authors who get it, there's some publishers who get it. But there's still an awful lot of black text on white paper being produced, and I don't think that that serves anybody We really need to learn things like color, video, animations, and audio, and I think I have my little cheesy. This is my favorite part. Now, maybe a good idea, maybe a bad idea, but the point is, it's something you don't normally do with a book. Maybe it gets people's attention, maybe it is unbelievably irritating. But the point is, it's different from what we're used to. What we need to figure out is what works where and why does it work and what does not work and what doesn't and why doesn't it work. Basically, we need to bring the concept of authoring out of the 1970s and bring it into the 2000s. And in my experience, publishers are doing a lousy job of encouraging authors in that direction, and authors, for the most part, are not taking it upon themselves to change the way that they've done things for decades. So that's kind of my vision for what I think we should be doing as authors, the way we should be approaching this. Anyway, if that's from 2009. So let's just take some really simple thing. I mean, this shouldn't be complicated. Let's talk about the use of color. So I can think of at least 4 things that I believe color can legitimately be used for. One of them is for code highlighting. So this is from Effective Modern C++. This is my book. I didn't do syntax highlighting, primarily because I did some posts to my blog. I asked people for feedback, and what I was told was that syntax highlighting on the short code fragments that I have wouldn't really be helpful. But using a second color to highlight what people should be looking at was helpful. So I decided to go with code highlighting. I think that's a legitimate way to use color on devices that support it. So syntax coloring, I think, is a completely legitimate thing to do. I looked at a lot of C++ books when I was preparing this talk. I was not able to find any C++ books which had examples using syntax coloring. So instead, I'm showing you one from Effective Ruby, which I don't know Ruby, so maybe that's syntax colored and maybe it's not, but it looks like it is. Diagrams and tables. So this happens to be from C++ concurrency in action. This is showing some time slicing of what's going on when you have a couple of threads being interleaved. I think that's a perfectly legitimate use of color. And I believe that for people who consume information on electronic devices that support color, that would include computer screens, that includes tablets, that includes some smartphones, people are used to seeing uses of color where it is appropriate, especially in some cases just to make things look a little bit more attractive. So this is from Bjarne Stroustrup's Programming Principles in Practice Using C++, which the interior of that book, in some ways, I think is a beautiful use of color. I really like this layout of the page. Now, this does not make the page any easier to read. It just makes it pretty to look at. And there's some other decisions made in that book that I would disagree with, but the point is, it's clear that whoever laid that book out was thinking about making it look visually attractive. And I think that's a legitimate use of color. So what I find kind of interesting is I took a look at some C++ books that were published either in 2012 or later, so within the last 3 years. So this happens to be the C++ primer. This is the 5th edition, so there's some code there. And there's a diagram from C++ concurrency in action, and there's a diagram over there from the Boost book. And, well, you can see them as easily as I can read them to you. And it sort of makes me laugh. So this is the C++ AMP book. Notice that they've used boldface. Now, the book itself, the printed book, is only printed in one color, black ink. So that makes perfect sense to me. But I was actually looking at the online versions of these books. And what I don't understand is why, as an author, you would choose to highlight something using boldface online when you could just as easily have used a second color and made it stand out a lot more. Still falling back on boldface, for example, in a single color book. So we have a long way to go, I think, to get to the point where people, as a natural inclination, start reaching for multiple colors. And I don't understand why in 2014 it's so easy for me to find books where everything is in black and white. That doesn't make a lot of sense to me. But I want to talk about a different problem here, which gave me a lot of trouble when I was writing Effective Modern C++. So this is a screenshot of my book. I think this is on Kindle. I don't actually remember what it's on. What I want you to notice here is I've circled all the lines that have wrapped incorrectly. So this is a pretty common experience with reading technical books on digital devices, which is all the lines wrap in the wrong places. There is no excuse for this. This is horrible. From my point of view as an author, this does not help me get my point across. And from your point of view as people reading information, or my point of view as somebody reading information, this just makes my job a lot harder. Now in this case, this is from my book, so the author has generously decided to put comments in a different color, so at least I can tell that it's not code. But if it were not in the second color, then it'd be really hard to figure out that this actually is a word that's wrapped around from this comment that came from over here. I spent a lot of time planning in effective modern C++ for dealing with this problem, and I published a blog post where I had some data about how many characters I could get in a fixed pitch font on a particular device under certain viewing conditions. So is it portrait, is it landscape, what is the size of the font that you've set it to, things like that. And ultimately I decided that the answer to life, the universe, and everything is not 42, I decided it is 64. So my conclusion was that if I don't put more than 64 fixed width characters on a line of code, then that is highly likely to display well on most devices under what I consider most reasonable viewing conditions. So if you have an iPhone in portrait mode and you've made the font as large as possible, I'm not going to worry too much about that. But if you have a tablet and you've got the font set at some reasonable size, it should look reasonable. It should not have these gratuitous line breaks. So this is something I think that publishers should have solved 10 years ago. And so far, from what I can tell, there's absolutely no interest in it. In fact, the only place that I know of that's doing some work on this problem, and it's not in the publishing industry, it has to do with the Clang project, and in particular their support for Clang format. How many people are familiar with Clang format? Okay, those of you who are not familiar with Clang format, you should familiarize yourself with it. Clang format is a tool that takes source code and basically it's a pretty printer. It rewraps it in certain kinds of ways, following certain kinds of rules. But it happens very, very fast. It can be done dynamically. And what that means is that there is no reason in principle why you shouldn't be able to be viewing source code on some screen and change the font size and have everything automatically re-indent itself in a way that you find reasonable as a reader, because it's customizable. At the very least, in a way that the author found reasonable as the person authoring the document. So I think that long term, in the same way that we're so used to web browsers dynamically wrapping lines of just prose text, we should get to the point where we expect exactly the same thing to happen with code. But that's not going to happen unless people push for it. And so far, the publishers aren't pushing for it. Vendors like Amazon aren't pushing for it. No one's really pushing for it. So I'm hoping to build up a groundswell of recognition of the problem so that we can start exerting some pressure on people to, I mean, really, who wants to deal with this nonsense? This is ridiculous. And as an author, there's not a lot I can do. I mean, the best I could do was to write lines that I thought were reasonably short but not too short, which I think is better than when I used to ignore the problem but doesn't really fix the issue. So that's what I have to say about writing. I want to talk about presentations, because that's another important way to get the information out to people. So most people probably give presentations at one time or another in a setting more or less like this. So you've got one screen, it's not that big, you can reach up and point to it. So here I am giving a talk on a day when my hair was really kind of out of control. But most people probably have either given talks under these conditions or have seen other people give talks under these conditions. So that's fine. The problem is it doesn't always look like that. So you can see right now, this is a much bigger screen. I can't really point to the top, although I've got my handy laser pointer with me. Sometimes it looks more like this. So this is Kevlin Henney giving a talk at the Norwegian Developers Conference this past summer. What you can't actually see here, I like Norway. They speak better English than Americans do. They speak better American English than Americans do. It's actually quite scary. But the speakers here, they're standing on a little platform, but what you can't see is there's no railing. So if you step about 1 foot too far, you fall about 6 feet. But you can see, so the screen's directly above you, not really an easy way to show what's going on. Sometimes there's more than one screen. So I was at a conference not too long ago, actually last month, so here I am. And you can see that the screen's been sort of asymmetrical. This was a fun conference because they kept changing what was appearing on this screen here, so you never quite knew what was going to be there. The reason I point this out is because you cannot make the assumption that you're going to be able to point to what it is you want people to be looking at. But that's not the big deal. This is the big deal. It is so easy to record things now. I am not surprised that at this conference, everything's being recorded. Most conferences I go to, everything's recorded. It is increasingly going to be the case that as presentations become smaller and smaller, inside companies, inside special interest groups, they're going to be recorded because it's easy, because it's useful. And when you record things, it changes everything. Everybody's on TV now. Makes a difference. So this is a talk that I saw Chandler Caroth give, Karen Feeding of C++ Dragons. This is at Channel 9, Microsoft's website. 114,000 views. I was at the conference. There were about 400 people in the room. That's 3 orders of magnitude more people at least viewing a few seconds of it online than viewing it live. So this is at YouTube. This was at BoostCon. Exception-safe coding in C++. 11,000 views. I don't know how many people were in the room. I wasn't at the conference, but probably no more than a couple of hundred. 2 orders of magnitude more people. This is a talk I gave at NDC. I like this especially, showing how the views drop off over time. But even if it was me, 6,000 views, there were probably 300 people in the room. Increasingly, the people you are presenting to are not in the room with you. They're not watching you give the talk. They're not watching you, use your laser pointer and stuff like that. They're watching a recording. Now, this particular recording, from what I can tell, is actually recording everything that's going on the screen, which means that maybe people who watch it at home will be able to see what I'm pointing to with the laser pointer. But it's very common for me to give presentations where there is a direct video feed that goes from my laptop into the video equipment, and there is nothing that shows up in terms of my hand waving, or especially the laser pointer, that will ever be seen. Which means that if you want to give effective presentations that will work for the majority of the people who will see them, you don't want to be waving your arms around. You don't want to be using laser pointers, because probably that information is not going to be captured in any usable manner for the people who will be watching it, the majority of the people who will be watching it. Which leads to the question, okay, what do you do if you want to highlight code? So this is an example from Sean Parent's C++ seasoning talk. He gave this also at Going Native in 2013. So what he does is he actually highlights code sections. So he builds it into the slide, so there's some code that needs to be highlighted, and then he highlights this down here, and then he highlights that up there, and he works on that. That's a fairly common way to deal with the problem of not being able to point at things. It's very effective live. It works just as fine for people who are watching the recordings. The advantages are it's very good for live audiences. They can see it just as well as they could see a laser pointer. It's great for remote audiences in case you have people who are watching, let's say, in a different location. I've given presentations where I was speaking to 5 different locations simultaneously. And it's great for people who are watching asynchronously, meaning they're watching a recording. So that works. But it's not perfect. It's a lot of upfront work for the speaker. A lot of upfront work for the speaker. Yeah, but we don't care about speakers. They whine. But it's also very inflexible, because if somebody asks you a question and they want to know about a particular piece of code, well, if your animation wasn't built to answer that particular question, to highlight that particular section of code, it's very difficult to show them what you're talking about. So it works for a canned presentation, but it's not great for handling questions or dealing with spontaneous comments. So I've been thinking recently about how can we give presentations which are effective for the people in the room, but are also effective for the people who are watching the recording or the people who are watching remotely, maybe live. And the only thing that I've been able to think of, and this is just an idea, is to have a way to electronically, dynamically change what's going on. So this is a short YouTube clip that I found.
I really want to draw your attention to this second point. Okay? And maybe that this slide has animations. So you can draw all over your PowerPoint.
So what he had to say is not terribly important, but what you could see is he's got a screen here. He can write on. He can use it like a laser pointer. He can highlight things, and I assume there's a way to erase all of that as well. But the point is, it gives him a way to spontaneously respond to questions and comments that may come in. So it's more flexible than the kind of highlighting approach, but it also would be captured on a direct video feed. So I haven't seen anybody using that in a technical talk, but from what I can tell, it is a reasonable approach to the problem. But I think that this is something we really need to think about, which is how can we convey all of the information that is present in a live presentation to people who are not watching live. And I've been using my silly little laser pointer here because that's what I'm used to. It works fine for me, and I don't have a better solution, but I am well aware of its weaknesses. So I just want you to go away with 3 ideas that I hope you can take away from this particular presentation. The first one is to base your guidelines on thorough analysis and solid technical arguments. Nothing is going to change the fact that when you're dealing with smart people, and C++ programmers are smart people, and you're trying to convince them of something, if you don't have a really solid technical argument, you're not going to go anywhere. Nothing will change that. Second thing is that when you write, and I hope that you do, write for modern digital devices. Don't just write under the assumption that it's going to be black ink on white pages. Even if you never plan to print something, a lot of people, whatever their writing environment is, whatever their software is, whatever their configuration is, it's set up for black ink on white pages. Now, I am not suggesting that everything should have, bright red letters on a blue background. I tried to show you some ways, though, that I thought that color could be used in a reasonable fashion to help get the message across, and I think that authors, whether they're technical or non-technical, should be thinking about those things at the time they produce their content. And as far as presentations go, I think you need to design your live presentations to be recorded. You design them under the assumption that they will be watched later by more people watching the recording. And try to come up with presentations that will work well in that environment. If they work well in that environment, they almost certainly will work well live in addition. But just because they work well live does not mean they'll work well in a recorded environment. And if you are interested in any of the topics which I've talked about today, I will make the PDF for these slides available. So you're going to have a chance to look at this information here. And with that, I will say, are there any questions?
Are there any questions?
Yeah.
I just want to mention that the use of color is a bit tricky because for some people are colorblind. It is a big problem when you only put information available through color.
Okay. Okay, so the comment is that when you are taking advantage of color, you have to take account in the fact that not everybody perceives color equivalently. There are some people who are colorblind. There's different kinds of color blindness. I believe that there are ways to deal with this problem. For example, what you can do is for one thing, you can be careful in the way that you choose your colors in the first place. The second thing is you can try to make the color choices user configurable on devices which support that. And the third thing is that you can provide color and then some kind of a backup thing. So what I did in Effective Modern C++ is I use red as a highlight color, but I also made it boldface so that in theory, if you can't see the coloring, you should at least be able to see that it's bold-faced. But I agree, it is definitely a consideration which has to take into account.
Hi, Scott. One question. Could you go into more detail regarding the emplacement into a quok? Especially, why do we need to allocate the key on the heap instead of doing it on a stack and then moving it into an allocation afterwards?
All right. So essentially the question is, why does it have to behave this way? So Let's find out. That's not what I wanted. Okay. I actually wrote this. Okay. So I don't know if you can read this. I'll read this. Basically, it's tables 102 and 103 in C++14. From what I can tell by looking at those tables, it is not permitted to create an object and then move it into the container. In other words, you have constructor arguments, so you take them. You are permitted to create exactly one object from them. So what we'd like to think is I'd create a key object. I wouldn't allocate a node, but I'd create a key object, do all the comparisons, and then if I could insert it, I'd allocate the node, move this into the node, and I'd be done. But from what I can tell from tables 102 and 103, it is not permissible to create the object in one location and then move it into the node. And like I said, every one of the implementations that I looked at behaved the way that I described. So either there is a remarkable coincidence in terms of the way that they're implementing things, or they're reading that table the same way that I am, which says that you can't do it that way.
Another question?
I'm sort of cheating because I have a remark, not a question. I wrote a hash map myself, and it is an open addressing hash map. So I had the problem of emplace not even knowing where to construct the object. So what I did was to split the emplace arguments in two, which is not compatible, of course, directly with the standard container. So it expects a fully constructed key, and only the value, the map value, is constructed inside the directly inside the container.
Okay, so basically for the hash containers, you have to have a key to find out where it's going to hash to, because you can't even do the comparisons until you get to the right hash bucket. Good point.
When you are counting the number of instructions in the in-place constructors for, say, vector, was that source code instructions or optimized object code instructions?
Okay, I want to point out that the data that I'm showing, they came from Howard Hinnett, so it's not what I did, it's what he did. And the second thing is, it's not instructions, it's number of functions executed. And so basically what he did was he wrote a class and he put print statements in each one of the functions so that he could be able to find out which functions have been executed, which means it is immaterial whether they were inlined or not. So we're not counting instructions, we're not counting time. What we're counting is how many functions are executed at runtime. Okay?
Another question?
But isn't this the wrong metric to determine performance? Because in the end, the compiler will inline every call, and so nothing gets executed, and the performance in the end is maybe better than with less calls?
It is perfectly fair to say that we cannot conclude from this whether there will be any kind of a performance difference. That's a perfectly legitimate thing to say. On the other hand, what we can say is that at least at this level of information, we know that in place and insertion are not behaving the same. It is possible that after the compiler's finished optimizing, they will work out to be the same, but what we can say is they don't start out the same. And as far as I know, Howard did not do any analysis to determine what does it look like in optimized code.
I have trouble understanding this because is the height of the colored thingies like the amount of how many times the function is called? Because, I mean, the L value reallocation.
The axis, this is how many functions are called.
But how can it be that something like one in place where you don't need reallocation calls like six moves?
This one here, for example?
Yes, I mean, how can that ever be?
I can't answer that question. I'd have to take a look at the Visual C++ 2013 library implementation.
So it actually means that it calls 6 moves.
Yes, I mean, yes, this is how many things are being executed. Stefan Lawade, when he saw these results, he goes, oh God, I have a lot of work to do. And I believe that in the beta for Visual Studio 2014, I think these numbers have become much better. But you can't make any assumptions about how good your library is.
More questions?
Hi, Scott. One short question for you. Exists some code analyzer for check if it's better use insert or emplace, or you know about some code analyzer? Because emplace is new or newest.
Oh, I'm sorry, what is your question again, please?
If there is some code analyzer for emplace or insert, or when is better use insert or emplace?
Okay, so is the question whether I'm familiar with a tool that would advise you on whether you should
exactly.
use an emplacement function or insertion function? Yeah. I am not familiar with any such tools. It doesn't mean that they don't exist, but I have not heard of any.
More questions?
We have a person over here.
Hi. So you said you had your version of your book was like links to the paragraphs, but as far as I know, there's no public internet links to your items, or like I know you published some of them on your blog, and it was very useful. But can you maybe publish other items or like make permanent links to your items? Because many companies, use your items as guidelines or like reinvent them again. And it would be more useful to just give a link to, your item somewhere, maybe a short abstract of an item if you don't want to publish everything.
Yeah, I was going to start by saying my publisher and I have one shared value, which is that we don't like giving everything away for free. So, now the idea of putting together sort of an abstract would seem reasonable. I'm not interested in doing that, not because I'm opposed to it being done, but just because it's a lot of work, and to try to figure out how do you. If I have, let's say, a 5-page item, I've already worked as hard as I can to make it short. So to try to make it even shorter is not something that I'm enthusiastic about. What I will say is that when we created the CD, the thinking was that a company would license the CD, and then it would be used internally, and they could link to it from there. That was the way we envisioned it being used. So certainly the idea of, I can understand the appeal of taking guidelines that you find useful, whether they're from me or from other people, and putting them on the internet so that everybody can link to them. I understand the utility there. Just as somebody who spent about 5 years eventually working on what turned out to be this book, I'm just not enthusiastic about having the full text available for free. So.
More questions?
We have one over on the far side of this is okay. So now you have to make him run back and forth. we're looking for a pathological, access pattern.
Hi, any particular recommendations about what software to use, what formats to use in order to write books so that it would be easy to produce versions of this book for different devices, for different screens, for printing, etc.?
I do not have any recommendation for what to use for writing books. Everything I've used, I've hated. I wrote my first few books in FrameMaker, which I hated. And then for my most recent book, I wrote the manuscript in Microsoft Word because I said it can't possibly be any worse.
Yeah. Hi, Scott.
I have to tell you something. Writing is I don't get this, okay? So Microsoft Word, it's not like it's a new program. It's not like it hasn't been around for a long time. And so I'm writing the book, everything's going along fine, and then I get to the point where I'm going to do the index, because I think indices are really important. And that's when I find out you can't change fonts in the index. There is no support in Microsoft Word for changing fonts in the index. What I find interesting about this is that you can change fonts in the table of contents, which is automatically generated, which suggests to me that they probably went out of their way to disable the logic when they're generating the index. It's probably more work to not support it. And then there is an in-house tool that O'Reilly uses called Atlas, which I did not use, but I've heard about Atlas. And the first thing they said was, you need to know you can't change fonts in the index. So what I will say is this. If I were to do another writing project at this point, I would not try to use a what you see is what you get base tool like FrameMaker or Microsoft Word, because when you get down to actually trying to finish things, they don't do what you want them to do. Both FrameMaker and Microsoft Word, for example, have these unbelievably arcane interior markup languages to try to let you do stuff that you can't do through the regular interface. So I would just go with some kind of a markup language. And whether I would go with, DocBook is one that I looked at. I didn't actually use it. Basically, I would do something in a markup language, and I would try to choose something which is pretty widespread so that there's a community that can do whatever programmatic transformations on it would be necessary for different devices. That's the best I can offer you.
Yeah, you talked about that you really like automated testing of some of your guidelines. What is your impression about your new book? How easily would be most of them be transferred, or especially this item we had over in place? Do you think it's doable in a compiler to give out warning? And my biggest question is, how long should we wait to get this automated stuff? Do you have any prior knowledge how long it took from, let's say, your first book until they made it into GCC? So maybe 1 year, 2 year, 10 year, 100 years. So.
Well, it took less than 100 years. I haven't sat down and counted the number of machine checkable guidelines in the new book. I know it's a minority, which makes me feel badly, but that's the way that it is. So my guess, and I am guessing, is it's probably between 10 and 15. There's an awful lot of considers and strives. Another one of my favorite words. I suspect that the guidelines that are unambiguous and can be machine checkable, you'll probably see software, either open source or commercial, doing that certainly in 2015, because it's just not that hard to check for, and there are companies that do nothing but implement things that check for coding violations. And I know that they've already started. There's already a couple of products that are checking, for example, for some of the stuff that Herb Sutter has blogged about. So my guess is it won't take too long.
More questions?
There's a hand up in the back.
How do you decide between what goes into your book and what you give away on blogs and talks that go up on videos online?
It's kind of happenstance, to be honest. I don't have any great calculation behind it. What I can tell you is that for Effective Modern C++, one of the ones that I posted was about, I wanted to give the advice to use no, I proposed use no except whenever possible, which I thought was a controversial guideline. So I wrote it up and then I submitted it for feedback, where I got some very good feedback, most of which boiled down to, oh my God, how dare you advise that, but everything you say is right. And that was an example where ultimately I changed the guideline. I think I changed it. Originally it was going to be use no except whenever possible, and I think in the final book it's declare functions no except if they won't throw. You would be amazed at how that change in wording calmed people down. So that anyway, that one will eventually be, so that was published because I wanted feedback. I also published one about using parentheses versus using curly braces to initialize objects, again, because I wanted feedback and I thought that my advice was a little bit controversial. So it was not uncommon for me to choose them when I wanted to get some feedback from a broader group as opposed to just my technical reviewers. I know that for the new book, we're going to be publishing, the whole first chapter is already out. We're going to be publishing, I think, 3, maybe 4 more guidelines. All the ones that were in my blog are going to go out in final form. And then we picked a new one, and I think it might be the one I presented here, or it might be the one that precedes it, number 41, which is about considering pass-by value, which I'm not a fan of, but I felt like I needed to address. So anyway, that's sort of how I choose, is by either I want to get feedback or I think they're interesting and insightful. We got a question here.
For me, a very interesting thing that I've learned from your talk is the word quacks.
Yeah, that's my term, by the way.
I think there was the expression sorted associative container also for things like that, which is a concept. And I thought that some of the rules applying to the in-place problem could be derived from a concept quacks, maybe.
Maybe.
So it would be then, I think, possible that the compiler somehow gives warnings for non-appropriate using of in-place, for example. But the last years I haven't heard so much about the development of concepts for the new C++ standards. Have you, is there a chance that concepts are coming back?
Okay, so I'll answer the second question first. There is a special technical specification for concepts, and my understanding is that it's this close to being released. So concepts are definitely, they're now called concepts light. They will probably be in C++ 17, and they will probably appear as a technical specification, I would guess, in 2015. So concepts are not dead by any means. What I'll remark about, I should say, quack, that's my term. Now, if you search the standard for container with unique keys, you will find that phrase. But there's nothing wrong with using emplacement on a container with unique keys as long as duplicates aren't going to be rejected. So for example, if you know that you're only introducing new values into, let's say, a hash table, then you have to create the node anyway. So the disadvantage that I talked about creating a node and if it's going to be rejected as a duplicate goes away if it's not going to be rejected as a duplicate. And typically, compilers can't know whether you're going to have duplicates or not. So I would be very surprised if somebody could come up with a reasonable algorithm for determining whether you should get that warning or not. Hence, consider.
Thank you for mentioning that writing and publishing in general is important, because I think we are publishing, it's not visible enough. And one thing I want to note, have you ever heard of AsciiDoc?
I've heard of AsciiDoc, and I think at one point I looked into it. I don't remember. There was a whole period of time, I think between 2008 and 2011, when I was blogging online about trying to find suitable writing tools, and I think AsciiDoc might have been one of the ones that I looked at, but I could be wrong.
There's some recent development. It's rewritten, it was in Python, and now it's written in Ruby. Mm-hmm. And I had a look just last week, and it was really convenient, and you can get everything. You have conditions for what format you generate. So if you have a presentation, you can include videos, or if you have online formats. And if you have a book, doc book, you can skip videos and everything. So it's.
No, that sounds really.
I think it's a good solution.
Can I change fonts in the index?
I guess so, because it's really hackable. You can change every generator, so every pattern that is generated may be changed.
Let me be clear here. When the answer to the question is it's really hackable, if I'm writing a book, I don't want to be writing a program to write a book. So, having said that, actually, my suspicion is that AsciiDoc would allow it, because the thing is it'd be completely consistent with everything else that they do. It's the WYSIWYG programming environments that try to hide certain things where it doesn't work. I will also say I actually have a list of writing environments where I hope to explore them at some point just to see what they're like, and ASCII doc is on the list. So.
To be honest, that's not your choice to choose the format, because you write for O'Reilly, says that to you, you can use Word, you can use LaTeX, you can use DocBook, and that is it. So,
You can generate everything. So you generate your DocBook.
but they have styles for using this format.
I keep waiting, for the last 25 years, I have an iterative process. I choose a tool to write a book. I write the book. I hate what I used to write the book. I then go to write another book. I say, I hated what I used last time, so I do some research to find out what I'm going to use to write a book. I choose something, I use it, I hate it. And this has been repeated every year for 25 years. So I keep thinking that someone's going to, I don't really want to go back to tech. I really don't want to go back to tech. But I will say, tech probably does everything I would like to do.
Only one sentence, try DocBook.
What's that?
Try DocBook, as I mentioned it before.
DocBook is on the list as well.
Yeah,
so,
of course. It's a text format, so you have the whole power in your hand. You can use grep and such stuff.
Okay. So, I think we should let these poor people go to lunch. We don't want one more question, maybe? Let's do one more question, and then you guys can be released.
Regarding employees back and the insertion functions, can we sometimes rely on return value optimizations and some other things, some other optimizations that could relieve us, because sometimes people rely on that optimizations to do much less work than we otherwise have to do.
It is reasonable to assume that as long as you fulfill the requirements for the return value optimization to be applicable, it is perfectly reasonable to assume that compilers will apply it. However, it is important to know that there's a lot of situations where you're creating temporary objects that cannot be eliminated through the return value optimization. So it is one optimization that is useful, and you can rely on it being implemented. But for example, if you need to create an object in order to create a key, in order to do a comparison, or in order to be able to compute a hash address, the return value optimization will not save you anything.
You should make an item about that, probably.
Okay, thank you.
In a future book.
And thank you all. So.